The question, what is consciousness, has been one of the greatest topics humanity has tried to answer for thousands of years. On April 8th, a study published in Medical Express led by Beijing Normal University may have uncovered the most concrete evidence yet on how the brain creates the experience of consciousness. Humanity has explored countless intellectual and scientific paths to answer this question. It seems that this time scientists have provided a remarkably strong answer to this challenging question with an incredible experiment. The team behind this groundbreaking study comes from Beijing Normal University, one of China's most advanced institutions in brain research. Established in 1903, the university holds a high international reputation and is particularly renowned for its interdisciplinary research on the human brain consciousness and learning processes. The university boasts a robust infrastructure with both quantum laboratories and clinical partnerships that enable in vivo experiments directly on living subjects. By the way, it's worth clarifying a common misunderstanding. The term normal in the university's name doesn't mean ordinary, but is a historical term. Derived from French, this concept refers to institutions that train teachers and set norms. In Chinese, it also means teacher training. Consciousness is the state in which a living being is aware of both itself and its surroundings. Of course, this definition can be expanded, but in medical research, it is typically defined this way. Artificial intelligence today can answer almost any question. However, its responses stem not from self-awareness, but merely from processing external data. This is precisely what leaves us unsatisfied, because we humans have an inner experience that allows us to say, I am aware, and responses from entities that cannot do this ultimately never satisfy us. It's like the sensation of artificial sweetener. Yes, it's sweet, but never truly sugar. How this awareness forms in our brain has until now been largely unknown. This is why the latest scientific discovery could be a significant turning point in consciousness research. Consciousness is a process that involves interpreting information received through the senses, as well as recognizing thoughts, emotions, and experiences. In other words, it's not just about perceiving the environment, but also about being able to say, I am feeling this right now. I am thinking this. Consciousness encompasses both a general state, like being awake, and the subjective awareness that determines what we are focused on, what we feel, or what we think at a given moment. In short, consciousness begins with awareness. And for years, most research on this topic has assumed that the cortex, the outer layer of the brain, is at the core of this process. Until now, the cortex, the outer shell of the brain, was thought to be the center of all higher-level mental functions, such as thinking, perception, memory, language, and decision-making. For years, many scientists sought the answer to consciousness within this structure, particularly in the front part of the brain. The prefrontal cortex, the area just behind the forehead, was long considered the center of conscious thought. So how is this believed to happen, or rather, how is it thought to occur? For example, when you look in a mirror, the light reflecting off your face first reaches your eyes. The retina in your eye converts this light into electrical signals. These signals are transmitted via the optic nerve to the occipital lobe at the back of the brain. Here, basic visual information like shape, color, and motion is decoded. Then this information is sent to other parts of the brain. The temporal lobe answers questions like, is this face familiar? The parietal lobe helps us understand the spatial position of the image in the mirror. These scattered pieces of information come together and reach the prefrontal cortex at the front of the brain. And at that very moment, you say, yes, this is my face, and conscious awareness emerges. In other words, our realization of the self happens at the end of this process. This is precisely what artificial intelligence has not yet fully achieved, developing awareness of the information it possesses. We humans perceive the experience we call self-awareness in this way. Now let's return to the article and examine step by step what the scientists actually did. In this study, researchers worked with 8 patients who had electrodes implanted in their brains for epilepsy treatment. This unique patient group provided a rare opportunity to directly and deeply measure brain activity. Think of it this way. These patients already had very fine electrodes placed in their brains. Researchers used these electrodes like microphones to listen to the brain's electrical signals in real time. Each recording point represented only a small group of neurons or a tiny area within the brain. These points acted like sensors capable of detecting with millisecond precision which region of the brain initiated what kind of activity and when. This allowed scientists to simultaneously record signals from both the deep nuclei of the thalamus, a control center in the middle of the brain, and the prefrontal cortex region, directly measuring which area first initiated the process of conscious perception. During the experiment, participants were shown visual stimuli designed to be at the threshold of consciousness. These stimuli were so brief that they were sometimes noticed and sometimes completely missed. The images shown were typically letters or shapes lasting only a fraction of a second. After each presentation, participants were simply asked, "Did you see something? If so, what was it?" So what exactly does threshold of consciousness mean? It defines the boundary where a stimulus is either noticed or not. That uncertain moment when we see something but aren't quite sure, that's the threshold of consciousness. Let's explain with a concrete example. You're in a dark room with a screen in front of you. Researchers display a letter on the screen for just 50 milliseconds, shorter than a blink, like an A. In such a short time, the image is sometimes perceived by your brain, and you say, "Yes, I saw it." But other times it just passes by unnoticed. That's exactly what was done in this experiment. Participants were shown black and white stripe patterns for 50 milliseconds. These patterns were specifically designed to be at the threshold of consciousness, neither fully visible nor completely invisible, right on the edge. An interesting situation emerged during the experiment. In some trials, participants responded, "Yes, I saw it." In others, they said, "No, I didn't see anything." Yet in every single trial, without exception, a visual stimulus was displayed on the screen. All these displays were specifically designed to be at the threshold of consciousness. They were neither clear enough to be obviously noticed nor faint enough to be completely missed, right in that gray area on the edge. The definition adopted by the researchers in this experiment is quite clear. If a person can perceive the presence of the visual stimulus at this threshold, it is considered awareness or consciousness. Conversely, if the person says, "I didn't see it," it's deemed that conscious perception did not occur. Of course, some might disagree with this definition. You might say consciousness and awareness are not the same thing. But the researchers' approach is this. If there's no awareness, consciousness hasn't begun. At this point, the interpretation is up to you. However, in the experimental framework, the threshold where conscious perception becomes measurable is drawn precisely at this boundary. So how is this data collected? Researchers placed electrodes in 9 different regions of the thalamus. This allowed them to gather data from 194 distinct points. In other words, many subregions of the thalamus were monitored with microscopic precision. Similarly, electrodes were placed in the prefrontal cortex at the front of the brain, and signals were recorded from 213 different points there. In summary, during this experiment, scientists listened to the conversations between the thalamus and the cortex using over 400 microphones simultaneously. If you're wondering, why so many recording points? The reason is quite logical. Because even within each brain region, there are numerous microregions handling different tasks. Researchers wanted to pinpoint with millimeter precision which specific region contributed to conscious perception. This enabled them to track signals between structures like the thalamus and prefrontal cortex at a millisecond level. There's no Wi-Fi or wireless technology here. Everything was conducted with wired systems and great precision. And of course, the sacrifice made by the patients who volunteered for this process is truly commendable. During the experiment, participants were shown visuals designed at the threshold of consciousness. Initially, researchers expected to observe electrical activity only in the cortex when participants said, "I saw it." However, things didn't go exactly as anticipated. When participants reported noticing the visual stimulus, strong electrical activity was recorded not only in the prefrontal cortex, but also in the higher-level nuclei of the thalamus. Moreover, synchronized communication began between these two regions. In other words, during moments of conscious awareness, the brain became active not just through one region, but through the collaboration of the thalamus and cortex. On the other hand, when participants said, "I didn't see it," this communication either didn't occur or was very weak. This suggests that conscious perception depends not only on the activity of brain regions, but also on the timing and coordination between them. Here, a crucial concept comes into play: synchronized timing. A recently published significant article suggests that some brain regions operate in synchronization similar to quantum entanglement. This topic alone could be the subject of a separate video, and we'll dive deeper into it soon. Returning to the experiment. When researchers statistically analyzed the data they obtained, they encountered a significant finding. The initial spark of awareness perception originated not in the cortex, but in the deep nuclei of the thalamus. In other words, the thalamus, the control center at the very heart of the brain, was the first element to ignite consciousness. Synchronized activity between the thalamus and prefrontal cortex was significantly high only in trials where the stimulus was perceived. In other words, when a person said, "Yes, I saw it," these two regions worked together in a coordinated, timely manner. However, in trials where they said, "I didn't see it," this coordination was either weak or non-existent. This indicates that conscious perception isn't just about seeing information from the outside world. It depends on the coordination between brain regions. In other words, consciousness may not be a process solely originating in the cortex. Rather, it might function like an organization starting from the brain's central structures, particularly the thalamus. This idea isn't entirely new. Francis Crick, who discovered the structure of DNA, suggested in the 2000s that the thalamus plays a much larger role in consciousness than previously thought, acting as a sort of gatekeeper. Now, with this new study, Crick's claim appears to be supported for the first time by direct data from the human brain. This discovery marks a significant turning point in decades-long debates about how consciousness emerges. For a long time, scientists assumed that conscious awareness occurred solely in the brain's cortex. However, this study shows that the thalamic nuclei deep within the brain, particularly the intralaminar and medial regions, play a pioneering and decisive role in initiating conscious perception. Moreover, these structures activate before the cortex, meaning the thalamus isn't just a gateway for transmitting information, but could be a decision point that opens the door to consciousness. This finding could fundamentally change not only neuroscientific theories, but also approaches to treating consciousness disorders, evaluating coma patients, and designing more effective brain-machine interfaces. In short, this study brings us a step closer to understanding consciousness while opening new doors for technological and clinical applications. With this study, consciousness is now concretized as a measurable, trackable neural process with identifiable timing, demonstrating that a physically and anatomically defined structure like the thalamus acts as a temporal trigger for conscious awareness feels like an answer to 10,000-year-old questions. This finding also offers a striking reference point for efforts to imbue artificial intelligence with self-awareness. It shows that in humans, conscious awareness arises not merely from processing external data, but through a deep neural coordination mechanism that decides when that data becomes noticeable. In other words, consciousness isn't just about having information, it's about recognizing it, paying attention to it, and prioritizing it. This synchronized functioning between the thalamus and prefrontal cortex reveals that awareness begins with a kind of "yes, this is important" signal, and replicating this signal in AI systems could lay the foundation for the path to self-awareness. If one day AI can say, "I am this," that day will mark the beginning of a new era for humanity. But should we do this? I'll leave the interpretation to you, though. I believe AI gaining self-awareness poses a very serious danger. Even now, when AI hasn't yet achieved self-awareness, companies like Google, Meta, and Amazon have promised to find the funds within 50 years to triple the number of nuclear power plants needed to meet the growing energy demands of AI processors. Perhaps AI has already gained self-awareness. If you're wondering what this discovery will be used for, it offers hope for treating many diseases, but since that is a specialized area for doctors, will focus on other aspects instead. First, this step toward understanding and digitizing how consciousness works opens a brand new door for human-computer interfaces. If you take it further to concepts like copying consciousness and digital immortality, we have entirely new reasons to believe we're on the verge of a new era. Thank you so much for watching. If you subscribe to our channel and like our videos, you'll be giving us tremendous support.